So R3 and R4 is acting like a host or server, whatever. ASA is having two interfaces, inside and outside. Server or host are having the gateway as R1 because I told you the existing network is there intact and we don't have to touch that network. Let's see the connectivity. One minute. Huh?
Hello?
Yeah, 1 minute. Huh? Okay. So if you see ASA, and when I say show mode, this is in my.
Munawar? Hello?
Hello. Yeah, yeah,
Can you hear me?
yeah, yeah. Tell me.
What topic we are covering? I mean,
Last time you were there, not? We did theory of transparent firewall.
okay.
Remember, we did theory for transparent firewall, and today we are doing how transparent firewall practically works, how you configure ASA for transparent mode, and how the traffic is passed through from ASA. Okay.
All right, okay. Thank you.
Yeah. So my ASA, when I see my ASA, when I say show firewall, you can see it's in router mode, and it was already configured for multiple context mode, and you have a lot of files here. So what we'll do, we'll convert this into mode single. Okay. Meanwhile, let's see, because I took a new lab, so okay, it's there. It's there. So we need to change this IP addressing. We need to make it E0 by 0 as 192.168.10.1. show IP INT brief. Ping 12.1.1, 12.1.2, ping 172.16.10.1. Okay. 3 and 4 are acting as a host. Okay. Gateway is 10.1. PC2 show IP INT brief. Okay. It's booting. Show IP route. So now you don't need these routes facing. You don't have any IP address on the firewall. Firewall is going to act as a transparent bridge, stealth firewall. Show interface IP brief. Okay. So that day I also told you that you cannot run your transparent firewall without making a BVI. BVI is nothing but bridge virtual interface. It's like a port channel which is representing like a group of interfaces, because see, your firewall is working like a transparent firewall, so it will never carry an IP address. But in order to manage your device, you need to have an IP address on that device. So like in switch you give interface VLAN 1 an IP address, same way on ASA also you have to give an IP address to your bridge virtual interface. And your both the interfaces are going to be part of a bridge group, which you can create, say, multiple bridge groups. And every bridge group can accompany multiple interfaces. It can go up to 64 interfaces, I told you last time. So same way you're going to make two interfaces, the member of this bridge group 1, and you're going to name them as outside and inside. So once you decide the name and security level of that interface, firewall is going to work accordingly and allow or permit the traffic. Show firewall. So when I say show firewall, you can see it's showing the firewall is in router mode. So you need to say firewall. See, when I said firewall and put a question mark, is giving me switch to transparent. Show run. You see that IP address option is now not available now. Initially, when you say show run, you get the option of IP address. Here you have no shutdown. Okay. And when you say show firewall, it's in transparent now. So what is the command? Firewall transparent. If you want to make him normal, then you have to say no firewall transparent. Show firewall. It's in router mode. So once again it has become what? Normal. Now you see there is an IP address option here. So I go here once again and say firewall transparent. Show run. So when I say show route, when I say show route, gateway of last resort is not set. Show interface IP brief. Okay. So I go here, interface question mark. You can see there's a word called BVI, bridge virtual bridge group virtual interface. How many interfaces you can create? 100. So I created the first one. I'm just going to keep an IP address to to this firewall. Okay. So you see, there's no shut command is also not there. It's going very slow. 1 minute. Show interface IP brief. So virtual interface, you don't need no shut command. Show MAC address table. Nothing is there. Static also nothing is there. Dynamic also nothing is there. What about R3? Show IP INT brief. Ping 192.168.10.2. He himself. 3. IP address is wrong. Okay. So see now that the traffic is not going towards the router. That is the gateway. Okay. Because in between there is a firewall. If I remove the firewall, we can go from one switch to another switch. Not an issue. We don't need this switch. We'll remove this. It's creating process. Just 1 minute. It's starting giving me problem. Okay. So I just cleared all the configuration. Okay, so this fellow is able to ping, both of them is communicating with each other, uh, 10.2 and 10.3. R1 is already having an IP address of 192.168.10.1. ASA loading, but the end-to-end communication is okay. Okay. Show firewall, show run. Okay, so I'll go here, interface E0, no shut, name if outside, bridge group 1. Interface E1, no shut, name if bridge group 1. So if you see show run, I made both these interfaces member of bridge group 1. Management IP is 10.10. First, let him try to ping his gateway 10.1. See, he is able to ping 10.1. He should be able to ping 10.2 and 3 also. See, initially the first question mark, you're trying to send an ARP request. It's not, or you can say ARP broadcast. ARP broadcast is only specific, no? You have a request where you are asking for a particular IP's MAC address. So when I say show MAC address table, you can see he has learned on outside he learned this 1000. So 1000 belongs to show interface E0. 1000 belongs to R1. So he learned the MAC address. How? When you try to ping 192.168.10.1, he requested with the help of ARP. Normally my switch don't do like that. My switch do what? He sends a broadcast on all the port except the port from where he has received the request. But this fellow sends ARP broadcast to find out the MAC address of a particular address. So when I tried 10.1, he sent the ARP request and he got 1000 on port outside. When I tried to ping 192.168.10.2, he did broadcast, might be on both the interfaces, but then he got the reply from inside interface. Now again, if I try to ping 3, he's doing that. See, from the same interface, he got the MAC address of 10.3 also. So when I say show MAC address table, On inside he got two MAC addresses. Dynamically he learned that. From outside he got only one MAC address. So when I say show route, see there is no routing here. But suppose if I want to send the traffic to some other network, okay, so I need to make a route, point it out towards my router, which is going to act as a gateway. So when I say show route, you can see there is a default route. So when I try to ping 12.1.1.1, 12.1.1.2, 172.16.10.1 and 10.2, and when I say show route, and when I say show ARP, see, in this case he has learned he has to just send the packet to 10.1 because he is also acting like a host. So hosts normally do what? If they want to connect a network which is not part of their LAN network, they'll always send it to the gateway, and gateway is going to make them get connected to the another network. So same way my ASA is also 100% depending on R1 to get him to all the other networks. So he's already learned the MAC address of the gateway. Okay. So now anytime if he wants to go on 12 or 172, he's going to send it to the gateway, and he know who is his gateway. 1000. Now what happened? Now R3 want to reach outside. So he should first reach gateway. So what is happening now when his packet is reaching here? On ASA, and when I say show CON in detail, you can see the packet is received by ASA from 10.2 inside, and he has to forward it on outside, that is 10.1, because he knows 10.2 also he knows because he has kept the MAC address in its MAC table, and he knows 10.1 also. So he forwards the ICMP packet here. So the packet is going out. So the packet is coming here. According to the MAC table, any packet wants to go on 192.168.10.1, it should be forwarded on outside. So he now knows inside, he now knows outside. He knows the MAC address of 10.1, he knows the MAC address of 10.2 and 10.3. Very important thing, the security level of this is also 100. So he is allowing the packets to go out. But I told you, return packet coming through security level 0. So he is not allowing. So I need to make an access list out underscore in permit ICMP any to come on host or network access group in interface outside. Show access list. Show CONN detail. Yes, working successfully. Earlier also only echo reply was not coming. There's a hit count here. If you want to make more specific, then you need to say what? Go here and say no. And you say echo reply. When you removed it, access group also gone. Shows access list only for echo reply, because echo request is already working. So at least now this fellow is going out. This fellow is also going out. Two and three. Access list getting a hit count. Now let's allow R7 to come in. First let's check whether he is able to come in. Telnet 192.168.10.2. Show run. Still not working. So now this time you see I allowed TCP any to come on this Cisco. Show CON in detail. TCP connection. Traffic coming from 172 to go on 192. If this fellow wants to do telnet, 172.16.10.2. Shows you in detail. This fellow tried to do telnet to this fellow. Here this fellow tried to do telnet to this fellow. Oh, sorry, 172 did telnet to this fellow. Here this fellow. Okay, sorry, this vice versa. 192.68.10.2 tried to do telnet to So source is this, destination is this, source is this, and destination is this. Show CONN detail, show access list, the hit count here. Anybody can telnet this. For this, you don't need a policy because they're coming from high to and going towards low. I hope you understood transparent firewalls working. Now you can do anything, like I told you, you can do any this thing. It will work smoothly. Okay. Now there's one more example I'll try to show you, that you want to run a protocol between this fellow and this fellow. Suppose this is your router which is connected to branch. So you can pass on the protocol also. But normally protocols are not allowed because this firewall will not allow OSPF to communicate between these two routers, that is R1 and R3. In the first example, I showed this as a host who's trying to do telnet. The second example, I did telnet from here, and this fellow allowed it. This fellow, this R3 and R4 is running OSPF between R1, and ASA has to allow OSPF traffic. How it is going to allow? So the question is, dynamic routing protocol lab, where you have to allow OSPF to communicate between R1 and R3. You must be knowing that you need to create an access list where you have to allow the protocol OSPF. Up till now we were allowing ICMP, TCP. Now you have to allow OSPF. So in OSPF you must be aware that we have two multicast communication. One is multicast address 224.0.0.5, which is a very common communication address for all the OSPF speaking routers to say hello. But the second one is a special multicast address which you will find only in BMA network, that is broadcast multi-access network, where whenever DR other routers, which routers? DR other routers want to communicate with DR, they'll always use what? 224.0.0.6. Who? DR other. DR other means one who are neither DR nor BDR. So anytime if DR other want to communicate with DR or BDR, they'll use this special address 224.0.0.6. If DR want to communicate with DR other router, he is going to use what? 5. So this is the only protocol where you have 5 and 6 as the two multicast address for communication. Don't forget to allow both these addresses. If you forget 6, then if it is a BMA network, they will not communicate with each other. At present, we have BMA network only, where you see R3, R4, and R1 is connected with a switch. Okay. ASA is also acting like a switch. So this is definitely a BMA network, broadcast multi-access network. Just creating a dummy network. This will be the IP address used for router ID. This will be the IP address used for as a network. So you see we have created two networks on R3 router. Create an OSP protocol. Loopback 0 will be acting as a router ID. Hard coding it. Network 10.2.2.1 255.255.255.255. Area 0 2.2.2.2 network 192.168.10.1 255.255. Area 0 show IP protocol. So the link and the subnet between them is 192.168, that is E0 by 0. When I say show IP OSPF interface, network type is what? Broadcast. R1 show IP OSPF neighbor, nothing. Show IP OSPF neighbor, nothing. So I need to say access list out underscore in permit OSPF any to any 224.0.0. Any to host 224.0.0.5 and 6 show access list. It is a only two routers, and if you don't want DR BDR election, Then you can go on interface E0 by 0 and say IP OSP of network point to point. Network type mismatch. Show IP OSP of interface point to point. Show IP OSPF interface point to point. Show access list. Permit OSPF any to any. Start. Start. Let's check. Hellos are going. Anyway, access list out underscore in permit IP any. Let's see. Show access list. Something else has to be also allowed. Okay. Full now. Show IP OSPF neighbor. Full. Okay. So this is the show run access list. access list out underscore in permit OSPF any. Show IP route ping access list out underscore in permit ICMP any to come on host 1.1.0 255.255.255.0 show access list access list permit any to come on host 2.2 for echo OSPF is continuously sending hellos 10.1 is sending hello on 224.0.0.5 so that traffic is continuously on you can see okay I hope you understood transparent firewall and how it's work okay I will end today lecture early because can you create ACL using Mac only? Yes, you can create ACL for Mac with Mac also.
Okay, thank you. What are the drawbacks for transparent? Because I only know that the transparent actually is good for when you have a data center that's running already and then you don't want to.
Drawback means there is a limitation. No? A lot of things you can't do. Like I told you, dynamic routing protocol on the ASA. You can't, but because it is purely working on L2, no? L2 activities. So the limitation that you normally have on the switch, if it is an L2 switch. So I'll give you like last time I showed you what are the limitation like I think you were not there. Okay. Just
Okay.
check my video lecture of last time, transparent. I will send you the recording. Okay. So there are a lot of
Okay.
limitation. Today, actually,